I welcome you to this Science Paper 1 representation of physics representation. So in this video, we are going to revise electricity, moment and transformer. Electricity, moment and the transformer. Okay, so let me not forget, if you are new to this channel, kindly subscribe for more videos. Kindly subscribe for more videos, kindly. Okay, so I'm going to start with a question. Okay, it's fine. Okay, I'm going to start with what? Electricity. So the question is saying figure 6.1 shows a 240 volts AC. So the abbreviation AC denotes what? Alternating current or alternative what? Current. The abbreviation AC denotes what? Alternating or alternative current. So apart from that one, we also have DC. DC in full we can say direct current. So the question is saying figure 6.1 shows a 240 volts AC mains supply connected to a television and two lamps. So we have two lamps. Each lamp is receiving what? 40 watts. Each lamp is receiving what? 40 watts. Then the television is receiving what? 120 watts. So now power is usually measured in watts. Power is measured in watts. Okay. Then this AC, the main supply, is producing what? 240 volts. The AC, the main supply, is producing what? 240 volts. So now, these resistors, they are connected in parallel. So resistors connected in parallel, they receive what? Same voltage, but different current. Resistors connected in parallel, they receive same voltage, but different current. So in this case here, the television is going to receive what? 240 volts, and each lamp also is going to receive what? 240 volts. Okay. Apart from that one, we also have the live wire and also the neutral wire. So a switch or switches are usually connected in the live wire. They are connected where? In the live wire for some reasons. So I'm going to explain. So the question is saying, in normal operation, the power supplied to each lamp is 40 watts. And the power supplied to the television is 120 watts. The first question, which is question A, is saying, calculate in normal operation, Roman numeral number 1, the total power supplied. The total what? Power supplied. So power is measured in watts. Power is measured in where? In watts. So now, in this case here, look at on the diagram. We have 120 watts. We have what? 120 watts. And each lamp is receiving what? 40 watts. And each lamp is receiving 40 watts. Okay. So for us to calculate the total power here, I'm going to say 120 watts plus 40 watts plus 40 watts. Since each lamp is receiving 40 watts, then the answer or the final answer is going to be what? 200 watts. The final answer is going to be what? 200 watts. Okay, so let's move on to the next one, which is question Roman numeral number 2. It is saying, calculate the total number of watt-hours, kilowatt-hour, of energy supplied to the circuit in 3 hours. So in this case here, or in this question here, they are asking us to calculate what? Energy. They are asking us to calculate energy. Okay, so energy is equal to what? Power multiplied by time. Energy is equal to what? Power multiplied by what? Time. So now the question is saying the total number of kilowatt hours of energy. So in this case here we need to make sure that power should be in kilowatt. Then time should be in hours for us to calculate the energy. Okay, so I'm going to say 1 kilowatt is equal to 1000 watts. 1 kilowatt is equal to 1000 watts. So in this case here, I'm going to take 200 watts. I need to convert 200 watts into kilowatt. So if I want to convert 200 watts into kilowatt, I need to divide 200 watts divided by what? 1000 watts. Okay, so I'm going to say 200 watts divided by 1000 watts. Then the answer is going to be what? 0.2 kilowatt. 0.2 kilowatt. So now, the time we have been given the time, which is what? 3 hours. Then the time, let me say the power, we have found the power in kilowatts, which is what? 0.2 kilowatts. So I'm going to say energy is equal to power, which is 0.2 watts, let me say, which is 0.2 kilowatts multiplied by 3 hours. Then the answer is going to be what? 0.6 kilowatt hour. 0.6 kilowatt hour is our energy supplied to the circuit in 3 hours. Okay, now when you're calculating the cost of electricity, also you need to make sure that power should be in where? In kilowatt. Okay, so now on this part, the next one, which is Roman numeral number 3, is saying the current, the what? The current in each lamp. The what? The current in each what? Lamp. Now, here I was saying resistors connected in parallel, they receive what? Same voltage but different current. Same voltage but different what? Current. So I'm going to say power is equal to voltage multiplied by what? Current. Power is equal to voltage multiplied by what? Current. Now, in this case here, I was saying resistors connected in parallel, they are going to receive what? Same voltage but different current. Then in this question, they are asking us to calculate the current in each lamp, not in 2 lamps, but in each lamp. So which means we are going to take the total power for 2 lamps. The total what? Power for 2 lamps. So in this case here, the total power for 2 lamps, it is what? 80 watts. 8 what? Watts. 80 watts. So I'm going to say power is equal to voltage multiplied by current. So now in this case here, power is what? For 2 lamps, it's what? 8 watts. Then the voltage, since they are connected in parallel, they are going to receive what? The same voltage, which is what? 240 multiplied by current. So as for current, we don't have. So which means for us to find the current, we are going to say 80 divided by what? 240. 80 divided by what? 240. Then the current is going to be what? 0.3 amps. 0.3 amps. Now remember, they are saying calculate the what? The current in each lamp. The current in what? In each lamp. So each lamp here, this 0.3 amps, it is the total current for 2 lamps. the total current for what? For two lamps. The total current for two lamps. Now, since these two lamps, they are receiving same power, which is 40 watts, which means they are also going to receive what? Same current. I hope you have understood on this part here. I'm saying these two lamps, they are receiving same power, same what? Power, which means they are going to receive the what? The same electric current. So in this case here, 0.3 amps, it is the total current for two lamps. Now they are saying the current in each lamp. So I'm going to say 0.3 divided by what? 2. 0.3 divided by 2. Then the final answer is going to be what? 0.15 amps. 0.15 amps. That one is what? Our final answer. Okay. Then question B is saying, explain why the switches are placed in the live wire and not in the neutral wire. So here I'm going to say, this is because the current flows where? In the live wire. Now, if you put the switch, let me try also to explain in this part here. If you try to put the switches on the neutral wire, and you know that current flows where? In the live wire. So if you put the switches in the neutral wire, you're going to find that even if you switch the what? Your appliances, you are going to find that current will still flow in the conductor. Okay, so I'm going to say to cut off the what? The electric current, because electric current flows where? In the live wire. So if we put the switches in the live wire, if we switch off the switches, the current will be cut off. Apart from that one, I'm going to say to prevent what? Accidents or electric shock. Then the next one, the next question, which is falling under what? Moment. It is saying figure 3.1 shows the brake paddle of a car, which is connected to a brake cylinder. So we have the brake cylinder, fluid inside the brake cylinder, the piston, and also the pivot, and also the brake paddle. So now in this part here, we have the distance from the pivot to where, force F is acting. It is what? Who can guess? It is 22 centimeters. Because the distance from the pivot to where 8 newtons is acting, it is what? 4 centimeters. Then from 8 newtons to where force F is acting, it is what? 18. Okay, let me say 18 centimeters. So the total distance from the pivot to where force F is acting, it is what? 22 centimeters. Okay, so now on this part here, when you talk of moment is just what? The turning effect of a force on a certain pivot. The pivot is more like a joint, okay, where the force acts. So now the question is saying the brake is pressed with our force F. This force produces a moment about the pivot. A moment about the what? The pivot. Pressing the brake causes a force of 8 newtons to act on the piston. To act on where? On the piston. Okay, right. So the first question, which is question A, is saying, define the term moment. So moment is defined as the turning effect of a force. The turning what? Effect of a force on a certain pivot. The turning effect of the what? The force on a certain what? Pivot. Now, under moment, we also have what? The principle of moment. So the principle of moment says that for a body to be in equilibrium, when you say equilibrium, which means the left side and the right side is balancing, or they are equal. So for the body to be in equilibrium, the sum of clockwise moment should equal to the what? The sum of anti-clockwise moment about the what? The pivot. Okay, so now moment, it has a what? A formula. So moment is equal to what? Force multiplied by distance, where force should be measured in newtons and distance in meters, not in centimeters but in meters. So whenever they have given you distance in centimeters, you need to convert that centimeter into what? Meters. So the next question, which is question B, is saying calculate the force F applied to the brake paddle. So here we are going to use now the principle of moment. So the principle of moment says that for a body to be in equilibrium, the sum of clockwise moment is equal to the sum of anti-clockwise moment about the pivot. So moment is equal to what? Force multiplied by distance. So in simpler way, or in summary, I can say F multiplied by F, then say F multiplied by D. It is going to represent what? The moment for anti-clockwise. The moment for clockwise, force multiplied by D is equal to force multiplied by D. Another force multiplied by D is going to represent what? The moment for anti-clockwise. So I'm going to say F is going to be my F1, then D is going to be my D1 is equal to F is going to be my F2, then D is going to be my D2. Okay, so we are calculating what? Force F. So force F we don't have, multiplied by distance. What is the distance from the pivot? The distance from the pivot is what? 22 centimeters. Now here I was saying you need to convert centimeters into what? Into meters. So we are going to say 22 centimeters divided by what? 100 centimeters. Since 1 meter is equal to 100 centimeters, 1 meter is equal to what? 100 centimeters. So I'm going to say 22 centimeters divided by what? 100 centimeters is equal to 8 newtons, which is force 2, multiplied by the distance from the pivot to where 8 newtons is acting. That is what? 4 centimeters. Even this one, we need to convert it. So I'm going to say 22 divided by 100, I'm going to get what? 0.22 meters. Multiplied by F, we are going to get what? 0.22 meters. F, which is the force, is equal to, when you convert or when you divide 4 divided by 100, we are going to get what? 0.04. Multiplied by 80 newtons, we are going to get what? 32 newtons meter. 32 Newton meter. From there now, we are looking for F. So which means we are going to divide by what? 0.22 meters. 0.22 meters. So our final force is going to be what? 15 newtons or 14.5 newtons. Okay, so I've just rounded off to 1 decimal place or to 1 figure, which is what? 14 newtons. Now, on this part here, I want you to observe something here. So, the distance from the pivot to where 8 newtons is acting, it is what? 4 centimeters. So, here we can conclude that the longer the distance, the less the force you are going to apply. But the shorter the distance from the pivot, the larger the force. Let me repeat. The shorter the distance from the pivot, the larger the force you are going to apply. But the longer the distance from the pivot, the lesser the force you are going to apply. Okay, so the next one is saying, which is question C, the cross-sectional area of the piston is 0.0012 meters squared. Calculate the power exerted by the brake piston on the fluid. So power, it is the force per unit area. Power, it is the force per unit area. And power is usually measured in Pascal. Power is measured in where? In Pascal, denoted by PA. Denoted by PA. Okay, so here I'm going to say Power is equal to, let me say pressure, not power. Sorry for that one. Pressure. So pressure is the unity, let me say it's the force per unity area, not power. So pressure is the force per unity area. So I'm going to say pressure is measured in where? In Pascal, denoted by PA. So pressure is equal to force divided by area. So in this case here, the force that we are going to take, it is the what? Force F, which is what? 15 newtons. Okay, it is force what? F, which is what? 15 newtons. So I'm going to say pressure is equal to force, which is 15 newtons, divided by area, which is 0.0012 meters squared. So when I divide, I'm going to get 12,500 Pascal. So pressure is equal to what? 12,500 Pascal, which is PA. Okay, so that was what? The last one for question 2. So let's move on to the next one, which is the last one, transformer. So the next one is saying, figure 8.1 shows a transformer which has a primary coil of 500 turns. The primary coil of what? 500 turns, and a secondary coil of 25 turns. So a transformer, it is just what? A device which can step up or step down the voltage of an AC. Remember, the AC is produced from where? From the mains supply. From the mains supply. So now under transformer, we have two types of what? Transformer. Let's say for example, you have what? 25 volts. You have what? 25 volts. Then you are having an appliance which is requiring, which requires what? Let's say 100 volts. 100 what? Volts. Now, for that appliance to work, you need to use what? A step up what? Transformer. Since here I'm saying the step up transformer, it steps what? It step up the voltage of an AC. So the step up transformer, it steps up the voltage of an AC. While the step down transformer, it steps down the voltage of an AC. Okay. So a transformer usually have two sides. It has what? The primary coil, and also the what? The secondary coil. Now when we talk about the step down and the step up transformer, the step down transformer, it has more turns on the primary coil and less turns on the secondary coil. The step down transformer, it has what? More turns on the primary coil and less turns on the secondary coil. Usually the primary coil is the input, then the secondary coil is the output. Now when you talk of the step up transformer, you are going to find that it is going to have less turns on the primary coil and more turns on the secondary coil. That one is the what? The step up transformer. Usually a transformer is made of what? Soft iron core. It is usually made of what? Soft iron core, for some reasons. Let me give you. So the reason why a soft iron is made of what? Soft iron core, because soft iron core, it is easily magnetized. It is easily to demagnetize also. It is easily what? Magnetize and easily to demagnetize. If you use steel, steel is going to form a permanent magnet. Okay, so let's move on to the question. So the question is saying, which is question A, calculate the secondary voltage of the primary coil if connected to, so this one was supposed to be 240 volts, not 2400, no. So 240 volts mains supply. So for us to calculate this one here, the first thing I'm going to give you the formula. So I'm going to say number of turns on the primary coil over number of turns on the secondary coil is equal to voltage on the primary coil over voltage on the secondary coil. Or if you multiply here, you're going to find that the formula is going to look like this. Number of turns on the primary coil multiplied by voltage on the secondary coil is equal to number of turns on the secondary coil multiplied by voltage on the primary coil. So in this case here, the question is asking us to calculate what? The voltage on the secondary coil. So I'm going to say, do we have the number of turns on the primary coil? Yes, we have, which is what? 500 turns. So, sorry for not correcting the data here, okay? Sorry for not correcting the data. So, the number of turns on the primary coil, we have what? 500 turns. Then, the voltage on the secondary coil, we don't have. So, I'm going to say Vs is equal to number of turns on the secondary coil we have, which is what? 25, multiplied by the voltage on the primary coil, which is what? 240 volts. Okay, 240 volts. Then from there now, I'm going to say, since I'm looking for the voltage on the secondary coil, since I'm looking for the what? The voltage on the secondary coil, I'm going to say, number of turns, it is 500. Then, the number of turns on the secondary we have, which is 25, and also the voltage on the primary coil, which is what? 240 volts. So I'm going to say 25 multiplied by 240, I'm going to get 6,000. So 6,000 divided by what? 500, I'm going to get what? 12 volts. So 12 volts, it will be the voltage on the secondary coil. So the transformer, this one tells that, this one concludes that the transformer in figure 8.1, it is a step down transformer because it is stepping down the voltage of an AC. On the primary coil we are having what? 240 volts. Now on the secondary coil we are having what? 12 volts, which concludes that this one here, it is the step down what? Transformer. So the next one is saying, which is question B, calculate the efficiency of the transformer if the primary current is 0.6 amps and the secondary current is 8 amps. Okay, so now on this part here, power is equal to what? Power is equal to voltage multiplied by current. Power is equal to what? Voltage multiplied by current. Now, efficiency, when you want to calculate efficiency is equal to what? Power output over power input multiplied by 100%. So now in this case here, power output, it is the secondary power. So I'm going to say, in the place of P, I'm going to say voltage for secondary multiplied by what? Current for secondary over voltage for primary multiplied by current for primary multiplied by 100%. So now in this case here, the voltage on the secondary coil, we have what? 12 volts multiplied by the current, which is what? 8 amps divided by 240 multiplied by 0.6 amps multiplied by 100%. So my final efficiency here is going to be, if I do the computation, my final efficiency is going to be what? 24%. 24%. So that was the what? The last one. Thanks for watching. See you next time. Remember to subscribe to my YouTube channel.